Hello everyone. Before starting today's lesson, try this warm-up. Display the data in a box plot. You have to remember what we did in the last lesson to remember how to make a box plot, but pause the video and try this. Because the numbers are already in order from lowest to highest, find the middle of the list. That's your median. We call it Q2, the second quartile. In this case, it's 13. Now you have 5 numbers in the bottom half of the list. So the middle of that would be the third one in, 8. So the first quartile is 8. Look at the top half of the list. The middle of the top half is this number right here, 14. So the third quartile is 14. When you make your box plot, just remember the box part contains your 3 quartiles, Q1, Q2, and Q3. Make a box around them. And then off to the sides, you have your minimum value and your maximum value. Make sure you have a consistent scale along the bottom and match up your lines on your box plot with those numbers. So you should have a box plot that looks like this. Today's lesson is about bar graphs and histograms. These are different ways of displaying one variable data. So you're going to be able to interpret data displayed in either a bar graph or a histogram, and also be able to display data in one of those bar graphs or histograms. So before we get into this, we have to talk about what data is. Data is just another word for information. And when you think about information, there's 2 main types of data. There's either categorical data, different categories, or numerical, which means numbers. So I have different types of data here that could be measured, and I want you to take a minute and sort the types of data, whether you think it's categorical or numerical. So pause the video and see how you do sorting this data by type. I'm hoping you came up with this sorted list. Favorite color, country of birth, and movie genres. If you collected this information, you would not get numbers. These are different categories. However, on the other side, age, distance, a test mark, these are all numbers, so these are numerical data. Now, categorical and numerical data can't be displayed in the same kind of graph. This makes sense if you realize that these are different types of information. So different types of information can't be shown the same way. So here I have 3 different graphs, and they're meant for different types of data. So what I'd like you to do is take a moment of time to talk with a partner or just think in your own mind, what type of graph is this? What's it called? And also, what kind of data would it display? Would it display categorical data, or would it display numerical data? So pause the video and see if you can come up with the names of these types of graphs and what type of data it can display. This is, of course, a bar graph. If you look on this examples, we have red, blue, green, yellow, pink. These are not numbers. These are different categories of colors. So this is categorical data. This, of course, is a pie chart, also called a pie graph or a circle graph. And if you look at this, it might be a little confusing because you see numbers. You might think this is numerical data. However, what are we measuring? We're measuring not the numbers themselves. We're looking at how many people liked each genre of movie. It's the genres of movies that are the variables that are being measured in this set of data. So because we're measuring genres of movies here. These are different categories. These are not numbers. The percent is just how many people voted for each one, but it's the categories themselves that are the data. So this is also for categorical data. Over here we have a line graph, and we see months and produce sales in thousands US dollars. So you might be thinking, well, months, that's not numbers. However, this is a time scale. Time is measurable with numbers. So although you don't see numbers here, you see names of months, these are numbers because you can measure time numerically. This is a flow of time. In between the start of October and the start of November, you can have 31 days. You can break that down into weeks, hours, minutes, seconds, and smaller than that. So we have a continuous scale of time, numerical data for a line graph. So all this to say, categorical data can be graphed with certain types of graphs. Numerical data can be graphed on a different kind of graph. We're not going to look at line graphs right now. We are not going to focus on pie charts. On the next slide, we're going to talk a little bit about bar graphs and then something else called a histogram. So here they are, a bar graph and a histogram. The bar graph is used for categorical data. A histogram is used for numerical data. Now, a lot of people get these two graphs confused because they look so similar. If you look at the data that's being graphed in this example, apple, orange, banana, kiwi, blueberry, grape, these are different categories of fruit. Whereas here, a mark out of 50, 0, 10, 20, 30, 40, 50. Think about that mark out of 50. You don't just have a mark of 0 or 10 or 20 or 30, etc. You can have a mark of any number in between 0 and 10, any number in between 10 and 20, any number in between 20 and 30, etc. Over here, these are separate categories. There's no continuum from apple to orange to banana, something between an apple and an orange, some weird hybrid fruit. No, these are separate categories, so the bars are separate. There are gaps in between the bars because they are not connected at all. Over here, you can have a mark of 0 or 10 or 20 or anything in between 0 and 10, anything in between 10 and 20. There's a continuum here. You can have 0, 10, or anything in between. So we don't see any gaps between the bars on the histogram. It's because of that continuous scale along the bottom. Bar graphs are used for categorical data. They have gaps. They are used to show a comparison of the different categories. I can look at apples, oranges, bananas, and compare how many people like each type of fruit. Whereas a histogram shows numerical data. There's no gaps in between the bars. And it's used to show an overall distribution of numerical data. So I can look at this, test marks out of 50, and I can see where most people had their marks. Most people had a mark between 30 and 40. The next most was between 20 and 30. And I can see one person had a mark less than 10. Two people had a mark greater than 40 on this test. So different types of data, again, have different graphs, and the way we read the graphs is different, and they have a different use. So what I'd like you to do now is look at each of these different situations and decide for yourself whether it would be best represented by a bar graph or a histogram. So remember, bar graphs are for categorical data, histograms are for numerical data. So pause the video and take a minute to think this out, write it down. What kind of graph do you think would be most suitable to graph each type of data? The number of cars in a parking lot each day. Well, we're measuring the number of cars. That's a number. That's numerical data, so we can graph that with a histogram. Monthly budget amounts for different expense categories. Well, you might be thinking, budgets, that's money, that's numbers. However, it's for different expense categories. Okay, so it's because we're separating the numbers into categories, that's where we're going to get a bar graph. Amount of time spent on homework each night. Well, time is measured in numbers. We're not breaking it into amounts of time spent on different subjects' homework. This is just homework in general, so there's not different categories here. Just the amount of time is the only variable, so we're going to use a histogram. And the number of people, you might think that's a number, but number of people who prefer Coke or Pepsi. So we're breaking that down into two different categories here. So because we have two different categories, this is categorical data, we're going to represent that with a bar graph. Now we're going to work through a scenario here. The scenario is this: Bob measured the heights of all his cousins. The heights are rounded to the nearest centimeter. So this table shows all the different heights of all his cousins. That's a lot of cousins. But if Bob wanted to display this data, would he use a bar graph or a histogram? I'm hoping that you said histogram because the only data that we see here is numbers. This is numerical data. Heights are numbers. We're going to use a histogram. Now, in order to make a histogram, we have to do something called a frequency table first. So I'm going to walk you through how to make a frequency table, and then I'm going to show you how to make a histogram. So first things first, the word frequency means how often a number or a thing occurs. So when we talk about the frequency of an interval, it's how often you have a value in that interval. Now there's some notation here. My interval, I'm separating this data, or I'm breaking it into intervals between 130 and 140, between 140 and 150, etc. These are what my intervals are. And the notation I'm using, you'll notice there's a square bracket and a round bracket. Over here, I'm just illustrating what that means. The round bracket on the 140 means that this interval does not include 140. The square bracket in front of 140 means that this interval includes the number 140. So the number 135 would occur in this interval. The number 145 would occur in this interval. The number 140 would not be included in this interval. It would be included in this interval. That's just a notation thing. Basically, if you see this, it means all the numbers between 130 and 140, including 130. So you can think of this interval as the 130s. You can think of this interval as the 140s, the 150s, the 160s, the 170s, the 180s, and the 190s. So what we're going to do is we're going to look at the table and just make a tally. How many times do you find a number in a certain interval? So I look at the first one, 154, that's in this interval. 175, that's in this interval. 166 is in this interval, and I keep going like this, building my tally sheet until I have a full frequency table. So I'm going to just skip ahead a bit here for time's sake. And here I have it. I went through the whole table. I counted up how many times I got a number in each interval. I made a tally, and then I used my tally to just write out what the frequency was. So what this table means is that there were 4 people with a height in the 130s. There were 2 people with a height in the 140s. There were 7 people with a height in the 150s, 5 people with a height in the 160s, etc. So now I can use my frequency table to make a histogram. And I've just cleaned up my frequency table a bit here so you can see the numbers more clearly. Over here, I'm going to draw my histogram. Now, the first thing you want to do is make sure that you're putting frequency on the vertical axis, like this. Now, on the horizontal axis, this is where you label your intervals. So my lowest interval started at 130. I went up by tens, and then the highest number is going to be 200. So on my histogram, I'm going to start at 130, go up by tens until I get to 200, like this. And now I just make the bars. So remember, this is not a bar graph. I don't label my scale 130 to 140, 140 to 150. I don't have separate labels for each category because it's not categorical data. This is a continuous scale from 130 to 200 and everything in between. So I label my axis like this. And so there were 4 people with a height in the 130s. So between 130 and 140, I make a bar that goes up to a frequency of 4. 4 people between 130 and 140. 2 people between 140 and 150, so I make the next bar. 7 people between 150 and 160, so between 150 and 160, I make a bar up to 7, etc. So we use the values in the frequency table to make the histogram. Now something for you to try. This histogram shows the heights of different black cherry trees in an orchard. So here's the histogram right here. Notice we have height in feet and the frequency. So 3 questions and a bonus. I'll leave them on the screen. You just pause the video and you try these on your own. Try to just interpret what the histogram is saying. So pause the video and take some time to answer these questions. And here you are. How many trees have a height of at least 65 feet but are shorter than 80 feet? Well, from 65 to 80, there's 3 plus 8 plus 10. That's 21 trees with a height of at least 65 but less than 80 feet. Part B, how many trees have a height of at least 80 feet? So that means 80 or more. So that means there's 5 plus 2, that's 7 trees at least 80 feet tall. Part C, how many trees are in the orchard? Well, 3 here, 8, 10, 5, 2. Add all those numbers together and we get 31 trees in the orchard. The bonus, find the percentage of trees which are at least 80 feet tall. Well, we know there's 7 trees that are at least 80 feet tall out of 31 total trees. So 7 out of 31, 7 divided by 31 is 0.226. That changes into a 22.6%. So 22.6% of the trees are at least 80 feet tall. And now it's time to practice. So use what you learned from the lesson to complete the worksheet. Enjoy!